If you recall from Algebra 2, an imaginary number is when you have the square root of a negative number. So the square root of -1 is what we call I. Okay, so if we have I equals root -1, what happens is if we took the square root of -1 times the square root of -1, then we would get just -1 for I squared. Okay, but I cubed is I squared times I, so you would get -1 times -√1, but -√1 is I, so then this becomes, let's go this becomes -I, okay? And then I to the fourth, we can take I squared times I squared, and -1 times -1 is just 1, okay? Well, I to the fifth is just I to the fourth times I, right? So that's going to end up just being I, because 1 times I is I. And then I to the sixth is going to be I to the fourth times I squared, which is just 1 times -1, which is just -1. And then I to the seventh is going to be I to the fourth times I cubed, which is just going to be 1 times -I is -I. I to the eighth is I to the fourth times I to the fourth, and that's just 1. So anytime you're trying to evaluate to figure out what I is, okay, if it is a perfect factor of 4, right? So I to the fourth times I to the fourth, I to the fourth times I to the fourth times I to the fourth, you're always going to get 1. So the question is, well, what about these? Like what happens with these? Well, if you take 11 and divide that by 4, right? That goes 4 goes into 11 3 times, and it has a remainder of 3. All right. So take the exponent, find the remainder when you divide it by 4. 10 divided by 4 is, it goes in twice with a remainder of 2. So I squared is just -1. And then I to the ninth divided by 4 is going to be 2 with a remainder 1. So this is just going to be I. Okay, so since I to the fourth is 1, it makes sense to divide by 4 because then you're just really multiplying this value of I by 1.